But review is for you. So if you don't invest anything in it, then you won't do it. I'm ready to go with vectors. So
Basically, is this the one that you did on the video where like you took
I took some from it, yeah.
Okay. Sabrina.
Okay.
Is there a review sheet?
Yeah. Papers I turned back and the review sheet, those are the sources of our questions that we have. So Lucy has her hand up. Lucy.
The 5152 quiz, number 1, I have 1 heart.
Did it say you're awesome or you're the best?
You're the best.
Alright, so we are again verifying.
I like this one. How did this turn out?
So I'm going to change this into sine over cosine. And change that into cosine over sine. Now these are two entirely separate fractions, so I can clean this one up by multiplying everything by cosine. And I can clean this one up by multiplying everything by sine. They're two separate problems. They do not, you don't have to do the same thing to both of them. So I've got cosine squared over cosine minus sine when I multiply by cosine. And then I have sine squared over sine minus cosine. Well, those denominators are almost the same, aren't they? Aren't they opposites of each other? So if I multiply this one by a negative, then I'll have the same denominator on both sides, or both fractions. So now I've got cosine squared minus sine squared over cosine minus sine. So I can factor out a negative or multiply top and bottom by negative, it doesn't matter however you do it. So now my denominators match. Now what about my numerator? It factors. And what's going to happen when I factor it? It's going to cancel with the denominator and leave me with what I want. Okay? What else? Either from a paper I turned back or from your review sheet. John, your hand up. Review sheet 3A, already did it. Apparently you didn't watch the video.
I watched the video.
So what do you want, 3C?
Sure.
So on the review sheet, I'm doing 3C. Wait, that's what I just did. This is exactly the problem I just did, isn't it?
What?
Yeah, it is.
I'm so sorry.
So far, we're not doing very well with our review, and I'm contemplating test tomorrow, because if this is what we have to do, I don't wanna waste any more time. Yeah,
Oh, it's wrong.
yeah, tomorrow's Thursday.
Should you do 1A?
1A. Now, you will have a reference sheet. So ideally, you will look at the pattern here. It's 2 times sine times cosine, and that's an identity. You look on your sheet. What's 2 sine cosine? 2 sine cosine is sine 2x. It's the formula for sine twice the angle. The angle is 100. So this is the formula for the sine of 200. But that's on your sheet. That's one of the double angle identities. Leah?
Actually, what is it? Can you do 4C?
4C is a solved problem, equation, and I'm to find all the answers in radians. And all, when we say find all the answers, what does that mean?
Oh, plus.
We need the coterminals, right? We need the plus or minus 2 pi n thing. But first of all, let's just go around the circle and find out where these answers are going to be. So I'll subtract root 3 and divide by 2. Cosine is negative. Where is cosine negative? Left side. So over here somewhere. And down here. Well, if adjacent's root 3, hypotenuse is 2, then opposite's got to be 1. And how big is that angle right there? 30, but in radians would be pi over 6. So just going once around, the answers would be this blue angle right here, which is what? 5 pi over 6. And then the red angle, which is 7 pi over 6. So if we were restricted to one revolution, then that would be it. Those would be the answers. But since we want all of them, we have to find all the coterminal angles. And how do we find coterminal angles? We add revolutions. And in radians, a revolution is 2 pi. You add or subtract a revolution. So that's all of them. Okay? Yeah.
What is the thing next to,
Says n is an element of the whole numbers.
oh,
That's your set notation.
do we put that for all of them?
Yeah. You gotta know what n is. When you say 2 pi n, what do you mean by n? You mean 1 time around, 2 times around, whatever. Okay? Liam?
We do 3E.
A 3e is another verified.
Like that
We have no identities for 3 theta. So we did one of these the other day. How do we handle, we don't have any identities for 3 theta. So what do we need to do?
break it down.
Take it apart and think of it as 2 theta plus 1 theta. And then we do have a mechanism for dealing with that. That is the sine of an angle plus an angle. That's on your sheet. The sine of an angle plus an angle is sine of the first, cosine of the second, plus cosine of the first, sine of the second. Right off my sheet. Now my problem's full of 2 thetas, but I have formulas for them, identities for them. What's the sine of 2 theta? 2 sine cosine times cosine. And then cosine 2 theta, that's one of those, that has, a bunch of different forms. I think I'm just gonna do, cosine squared minus sine squared. And see what happens. There is no wrong answer, just sometimes one way makes it quicker, but there's no wrong answer. All right, so I'll distribute over there. This is actually gonna be 2 sine cosine squared. And then this is gonna be cosine squared sine minus sine cubed. All right, things are looking up here. What about these two right here? What are these? Aren't they like terms? So you got 2 of them and 1 of them, so we have 3 sine cosine squared minus sine cubed. There it is. Now that identity caused us absolutely no stress at all. I mean, it was cut and dried. There's no trickiness, just do what we can do.
So it doesn't matter that 3 is the coefficient to the sine, but like in the problem that's written out, it's the coefficient to the cosine squared.
Okay, now keep in mind that's multiplication.
Okay.
So what do we know about multiplication? Order doesn't matter, right? When I multiply 3 things, yeah. So no, it makes no difference.
Can we do 12D on the chapter 5 review?
12D. Already done.
What?
It was done in class. Who asked me for that? The wedge of cheese. You already did. We did it already. Watch the video. Liam?
Quiz 5354. I had you got this one hard, number 2.
I don't know where my key is for that. Just tell me what the problem is, because I don't know where my key is.
If sine of m equals -7 square root over 4. Square root of -7.
Okay,
And then m is between 3 pi over 2 and then 2 pi.
so that means it's in quadrant 4.
And then find cosine of m over 2.
So first I'm gonna draw a picture of what I was given. So in quadrant 4, I know the sine is -√7 over 4. So I'm gonna do my Pythagorean theorem and figure out what the missing side is. So what will that missing side be with the Pythagorean theorem? 3. 16 minus 7 is 9, square root of 9 is 3. So that's the given. Now I need to figure out the cosine of m over 2. So that identity is on my sheet. 1 plus cosine over 2, is that, I think that's right, isn't it? Did somebody double check that on your sheet, is that right? Okay. So now, I need to plug in the cosine of m. Well, what's the cosine of m? 3/4. So I have 1 plus 3/4 over 2. Now, somehow you have to clean that up. I would multiply everything by 4. You don't necessarily have to do it that way, but that's how I would do it. So I end up with square root of 7/8. Let's see, I'd really like that denominator to be not a radical. So what if I times by 2? Would that give me the square root of 14 over 4? That looks pretty good, doesn't it? But now I gotta choose plus or minus. Anytime you're using one of those half angle identities, you have to pick. So go back to the beginning. N is in quadrant 4, which means it's between, in degrees, it's between 270 and 360, right? I'm trying to figure out half of that. So where's half of it? between 135 and 180, which means it's in quadrant 2. And what do I know about cosines in quadrant 2?
And is that formula right there, the square root 1 plus whatever, is that on our formula sheet or where did you get that?
It is. Why do you not have your sheet out looking at it?
Great
That's
question.
a great question. All right, who else? Liam?
Chapter 5 review number 8.
Find the area of a regular octagon. Inscribed in a circle with a radius of 9. So a regular octagon, that's 8 sides. Inscribed in a circle with a radius of 9. All 8 triangles are congruent, right? So we're gonna find the area of one of those triangles and just times it by 8. Now, I don't know all 3 sides, so I won't be doing Hero's formula. Life would be great if I knew that angle right there. Do I know that angle? 45 degrees. Because all these triangles are congruent, there's 8 of them that are making 360, 8 of those central angles there making 360. So the area of the triangle is 1/2 side, side, side. So whatever that is, I'll just take it times 8, and that will be the area of the octagon. Right? All right. What else?
Is that 1/2 base height, side 45?
Hmm?
Like right there, you did the area for the
It's
individual.
1/2 side, side, side. One of our area formulas. You need to make sure you're watching the videos, okay? Lucy? 6B. Ooh, I can, but guys, this is exactly like one I already did, only the one I did was a cosine. Oh wait, no, this one's an inequality. Okay, yeah, it's a little different. Because it's not an equation, it's an inequality. Now, what if it were an equation? Let's start with that. What if it were an equation? Well, I just figure out where is the sine negative root 3 over 2 in radians. So where is the sine negative root 3 over 2? Well, where's the sine negative? 3 and 4. And root 3 over 2, how big is that reference angle? 60, which is pi over 3. But pi over 3 isn't an answer. An answer would be this, which is 4 pi over 3, pi plus, and then this one, which is 5 pi over 3. Now, this is the answer, we're not done, that's not the answer. But those are the 2 angles in this interval where the sine is exactly root 3 over 2, right? Oh, negative root 3 over 2. So I'm going to look at my sine curve for a minute. Going from 0 to pi over 2. Here's my sine curve, or 2 pi. Just my regular old sine curve. And there are two places on there, namely right here and right here, where the sign is negative root 3 over 2. Right here at 4 pi over 3, that's 1 1/3. And this is 5 pi over 3, which is 1 2/3. Those are the two places where the sign is exactly negative root 3 over 2. I want to know where it's more than that though. So where is the sign more than that? All of that and all of that. So what angles is that? 0 to 4 pi over 3, or 5 pi over 3 to 2 pi. So, you're looking at that thinking, that wasn't in our notes. Well, no, but how do we do inequalities? How do you graph, like if you had to graph x plus y is greater than 2, wouldn't you start by graphing a line? You would graph it and though it were equals, and then what do? Since it wasn't in equals, once you get it graphed, you shape. So what did I do? I graphed it, and then I shaded it and looked for the part that was above the two values that I had. All right, so I think what we're gonna do is we have lunch again tomorrow. We're gonna review the first part of the period before lunch, and then I think we'll start chapter 6. Unless you come with ample attempted problems. We're not gonna do what we did today. We're not gonna sit and stare at each other and wait for you to just randomly pick a problem. Put some time and effort into it. Come with good review questions.